Last episode, an analyst stared at a phishing alert and asked the model why, and SHAP handed back a one-line story. But here's the thing nobody warns you about: that alert was one of hundreds, and the number of alerts isn't set by the attacker. It's set by you the moment you pick a threshold. Ship the default 0.5, and you don't know how many alerts you just signed your SOC up for tomorrow. This is the most operational knob in the whole course, and almost everyone leaves it on autopilot. The misconception this episode kills: a classifier outputs a label, so the model decides what's an alert. It doesn't. XGBoost outputs a score between 0 and 1, and a threshold turns that score into a yes, no. Move the threshold and the same model, same weights, becomes a different detector. We draw one score line from 0 to 1 and slide a cut point along it. Everything above is an alert, everything below is silence. Misconception: 0.5 is the natural cutoff. On security data, it's an arbitrary leftover. At 0.5, our phishing model fires on far more than the SOC can read. We show two thresholds on the same scores: 0.50 lighting up a wall of red alerts, 0.805 trimming it to a readable handful. Same model, wildly different day. Misconception: recall and precision are model properties. They're threshold properties. As we raise the cut from 0.5 toward 0.9, three curves move together. Precision climbs to 0.965, recall sags to 0.76, and FPR drops towards 0.7%. There is no free lunch. Every attack you insist on catching costs you benign alerts. Now, the security honest move: turn FPR into a number our SOC manager actually feels. Our feed is 50,000 URLs a day. In this seeded world, about 80% are benign, roughly 40,000. An FPR of 0.7% on 40,000 benigns is about 280 false alerts a day. We draw the alert count axis right next to FPR, so 0.7% reads as 280 humans. Have to look at this. The budget. Suppose the SOC can triage 300 alerts a day. That's the amber line. We don't ask what threshold is best in the abstract. We ask what's the highest recall I can buy while staying under 300. That flips the whole problem. The budget is the constraint, recall is the price, threshold is just the dial we turn to spend it. Misconception: pick the threshold that maximizes F1, UDEN, accuracy. Those ignore your capacity. We slide the cut down from 1.0 until the alert count reaches the 300 line. That's threshold 0.05, about 280 alerts, recall 0.76. That's the highest recall we can buy without blowing the budget. And precision is still 0.965, so it's the shippable pick. The payoff line: the threshold isn't a tuning afterthought, it's a staffing decision. One number sets how many attacks slip past and how many analysts burn out. We freeze it: 0.805 to recall, 0.76 precision, 0.965 FPR, 0.7%, 278 alerts per day under a 300 budget. Open 13 threshold fp budget.py. We rebuild the exact EPS02 house dataset, seed 42, same renamed phishing features. So the model and its scores are byte identical to where this series started. No retraining surprises, we're only changing the decision, not the detector. Lines 1 to 22, regenerate the phishing house data with make classification random state 42. Rename columns to URL length, num dots, has HTTPs, subdomain count, entropy, age days, and keep the seeded feeds all on 20% phishing prevalence. Same train test split random state 42 as F402. So the held out scores match the PR AOC 0.958 house number we've been carrying. Lines 23 to 32. Train the same XGB classifier with scale pose weight for the imbalance, the APO3 lesson. Then call predict pro by X test. 1 to get the raw scores. Critically, we never call .predict. Predict secretly hard codes 0.5, and 0.5 is the thing we refuse to trust. Lines 33 to 48. the sweep. For each threshold from 0.05 to 0.95, count true, false, positives and negatives by hand, then compute precision recall and FPR at that cut. We scale FPR into a daily alert count, alerts. FPR benign per day, with benign per day, the 5001 prevalence. This array is the figure. Lines 49 to 58, apply the budget. Budget 300. We find every threshold whose alert count is under budget and pick the one with the highest recall. Operationally, catch the most attacks I can afford to look at. It lands on 0.805. We print the frozen line so terminal figure and headline are the same numbers. Lines 59 to 70. Plot three curves against threshold, precision recall, FPR as alerts. Drop the amber horizontal budget line at 300 and mark the chosen 0.805 with a vertical rule. The white figure card makes the amber line and the red recall curve pop against the SOC dark tech. So don't ship 0.5, sweep the threshold, draw your FP budget as a line, and read off the recall it buys. That single choice sets your analyst's entire day. But there's a quieter assumption baked in here. We trusted that more failed auth and higher entropy only ever make a URL more suspicious. What if the model, left alone, learns a kink where more risk somehow looks safer? Next episode, Cyc-14, encoding threat model priors. We hand XGBoost monotonic constraints so it can't betray what security already knows.